All right, in this video we're going to be looking at a couple examples from the chapter 6 notes. Specifically, I think we're going to look at 4 equations, and I'm going to show you how to solve the equations using the change of base formula as opposed to isolating the exponential and using the power rule of logarithms. So just a slightly different approach. The steps are pretty similar. First thing you're going to do is you're going to isolate the exponential expression or possibly expressions. Then you're going to rewrite in log form. So if you have b to the y is equal to x, that's equivalent to log base b of x is equal to y. And then you're going to use the change of base formula. Log base b of x is equal to the natural log of x over the natural log of b. And you could use log base 10 also, so log of x over log of b. That would work also. Those are the logs that are most common to being on the calculator is the natural log, which is base e, the Euler's number, the 2.71, etc., and the common log, which is log base 10. So again, so we have the natural log. So ln of x is log base e of x, and then you have common log, which is log of x, and that is log base 10 of x. Okay, so we want to use one of these when we use our change of base formula, because that's what our calculator is going to have. Okay, so let's go ahead and move on to, so this is going to be problem number 15 for the notes. So, there's another video where we solve these slightly differently. So we have 2 to the x is equal to 41. And of course, the first thing we're going to try to do is try to get a common base, but there's no common base between 2 and 41. So what we're going to do is we're going to rewrite. So this is going to be log base 2 of 41. And remember, your logarithm is the exponent, so that's going to be equal to x. So that is solved for x, but if we want to get a numerical approximation, we use our change of base formula. So log base b of x is equal to the natural log of x divided by the natural log of b. So then we would have the natural log of 41 over the natural log of 2 is equal to x. And if you're using a calculator like a TI-30 X2S, that's the one I recommend, you would hit the natural log button. That's 2 buttons down from the second function on the left side of your TI-30 X2S. And it's going to give you an ln with an open parentheses. We'll put the 41 in there, close parentheses for the natural log, and then division, and then the natural log button again, 2, and then close the parentheses. And so we get approximately 5.357 and that's going to be rounded to 4 decimal places. So, depending on what the application is, if it's like money, then it would make sense to maybe round to the nearest cent. If not, then I would say 4 decimal places is probably playing it safe, unless the problem specifically, asks for a different decimal value. Okay, moving along. Number 16, we have 4e to the x minus 1. Sorry, not minus 1. Minus 16 is equal to 6. So we're going to isolate the exponential expression here, which is e to the x. So imagine you were solving 4x minus 16 is equal to 6. So the first step you would do was add 16 to both sides, and then you would divide by 4. And that's going to isolate the x. So here, instead of x, we have e to the x. That's our exponential expression. So we add 16 to both sides of the equation. And so we have 4e to the x is equal to 22. We'll divide both sides of the equation by 4. So we'll have e to the x is equal to 11 over 2 after we reduce. Now, if we have the natural log of y is equal to x in exponential form, that is e to the x is equal to y. So we're going to go in reverse there. So we're going to have the natural log of the 11 over 2. And remember, the natural log, or any log, is the exponent. So the natural log of 11 over 2 is equal to x. In our calculator, we hit the ln button. We're given a parentheses, and we'll put in 11 divided by 2, close our parentheses. And rounding that result to 4 decimals is 1.708. All right, just a second. All right, number 17, we have 4 to the 4x minus 3 is equal to 46. Again, we can't get a common base here. The exponential is already isolated, so we can go ahead and rewrite log base b of x is equal to y is equivalent to b to the y power is equal to x. So we have log, and the base is 4 of 46, and that's going to be equal to the exponent of 4x minus 3. So we're going to solve for x. We're going to add 3 to both sides of the equation. Log base 4 of 46 and 3 are not like terms, so we're not going to combine them. So the best we can just say is log base 4 of 46 plus 3, and that's going to be equal to 4x. And to finish isolating the x, we're going to divide both sides of the equation by 4. So we're going to have log base 4 of 46 plus 3 divided by 4. That's going to be equal to x. Okay, so that's all for x. Now if we employ our change of base formula, log base b of x is equal to the natural log of x over the natural log of b. We're going to have x is equal to, so we're going to convert the log base 4 of 46 as the natural log of 46 divided by the natural log of the base, which is 4, and then plus 3, and then divided by 4. So that's our exact form. If you want to put this in your calculator, you're going to need a parentheses for the entirety of the numerator, so parentheses in the natural log of 46, close that parentheses, divided by the natural log of 4, and close that parentheses, and then plus 3. Then we need to close the parentheses for the numerator, and then divide it by 4. When we put that into our calculator, we're going to get approximately 1.4404. Okay. All right, one more. Number 18, we have e to the 4x is equal to 21. So if I have the natural log of y is equal to x, we can rewrite that in exponential form. So it's going to be e to the, hold on a second. So we have the natural log of y is equal to x, so we have e to the x is equal to y. So we're going to have a natural log of 21 is equal to 4x. And to finish solving, we'll divide both sides by 4. So we have x is equal to the natural log of 21 over 4. There's our exact form. And our calculator, it's going to be the natural log of 21. Close your parentheses, divided by 4. Okay, and so x is approximately 0.7611. Okay. All right, so that concludes this video here. So just looking at solving some of those exponential equations where we could not get equal bases, and instead of using the, basically we say we take the natural log of both sides and use the power rule. Here we're just rewriting in log form and then using the change to base formula. Alrighty, we'll see you next time.